Welcome to topic 2. We're going to talk about quadrilaterals, which we already mentioned on topic 1, and parallelograms. A quadrilateral, as you know, quad means 4, is a 4-sided polygon, and a parallelogram is which both pairs of opposite sides are parallel. So you can see in this picture, QP and RS are parallel, and QR and PS are parallel. And the notation that we use for parallelograms is this little slanted rectangle in the letters in order, P, Q, R, S. Okay, now we're going to go through what it means to be a parallelogram. Besides the parallelogram having opposite sides that are parallel, it also means opposite sides are congruent. And how can we know this? So if I draw a diagonal here, and I can split this up into, by AIA, angle 1 and angle 2 are congruent, and also angle 3 and angle 4 are congruent. And I know by the reflexive property, PR is congruent. By ASA, I have two congruent triangles. That triangle PQR is congruent to triangle PSR, which means all the parts are going to be in this parallelogram. Also means I have congruent sides, backwards and forward, which both ways. And if I have a parallelogram, it also means opposite angles are congruent. Well, I've already shown that triangle PQR is congruent to triangle PSR in the first figure here. So now that means angle Q is congruent to angle S. Now by drawing the diagonal the other way, I have shown that triangle PQS is congruent to triangle RSQ, which means angle P is congruent to angle R, and I've shown all four angles, all opposite angles are congruent. If I have a parallelogram, that means QR and PS are parallel to each other, and that means this angle here at Q and this angle here at P are same side interior angles, and they're supplementary, which means they add up to 180 degrees. So AB next to each other equal 180, and so on and so forth. And finally, if you have a parallelogram, the diagonals bisect each other. That means diagonal QS and diagonal PR meet in the middle at point M, and they bisect each other. For my diagram, angle 1 and angle 2 are congruent because of alternate interior angles. Angle 3 and 4 are by the same process. And I know QP and RS are congruent because it's a parallelogram and opposite sides are congruent. That means the triangle on the left, which is PQM, and the triangle on the right, RSM, are congruent, which means QM is equal to MS by congruent parts of congruent triangles, or corresponding parts of congruent triangles are congruent. And then finally PM is equal to MR, and so on and so forth. And there we go. We're going to use these properties. I can also prove something is a parallelogram. I need all opposite sides are congruent, all opposite sides are parallel, or one pair of opposite sides are congruent and parallel. So by side angle side, I do the diagonal. Angle 1 is congruent to angle 2 by alternate interior angles. BD is congruent to itself. So by side angle side, angle ABD is congruent to triangle CDB, which means AD is equal to BC, which means I have both pairs of opposite sides congruent, and there we go. It is a parallelogram. Okay, I have parallelogram NNOP. If MN is congruent to its opposite side, PO. ON is congruent to its opposite side, PM. PQ is part of the diagonal, and that's congruent to QN. Angle MQN, this top angle, is congruent to angle OQP. MN is parallel to PO, opposite sides are parallel. MPO, this bottom left angle, is congruent to the top right angle, angle MNO. And QM, which is this half of this diagonal, is congruent to the other half, QO, since diagonals bisect each other. And angle NPO. NPO is this angle right here, near the bottom left, is congruent to angle PNM. Okay, these are all parallelograms. I have to find a value for x and y, whatever the variables. And I know this top side is congruent to this bottom side. And I do 3x minus 7 is equal to 2x plus 9. I solve for x. I got x equals 16. And I know these two sides have to equal each other. So 5y equals 2y plus 18. I do some of my algebra. I get y equals 6. I know in parallelograms that the diagonals bisect each other, so I know that 12 and 3x plus 6 are equal to each other, and I do my algebra, and I got x equals 2. And then the other diagonal, I know that these two are equal to each other. I do my algebra, I get y equals 9. I know that opposites, opposite angles are congruent, so I know these two are congruent. 3x minus 18 equals 2x plus 12. I get x equals 30. But then I also have to realize what else I have. And I know that consecutive angles, or same side interior angles, are equal to 180. So I plug 30 in here, and I plug 30 in here. I get 90 minus this angle is 72 degrees, and this angle also here is 72 degrees. So I have 4y plus 72 is equal to 180. And I get y equals 27. And I also get 3z plus 72 is equal to 180. And what I do for z, I get z equals 36. I'm going through the algebra quickly. You could do that on your own. It's not really that difficult. Again, diagonals bisect each other, so I know these two are equal. I get x equals 12. And I know that these two are going to be equal. So y equals x minus 5, or 12 minus 5. Y equals 7. I know P is the midpoint of either LN or MO. So P is the midpoint of LN or MO. It's up to you. And the midpoint formula is I add the x's. 1 plus 6 divided by 2. Add the y's. 4 plus 0 over 2. The point P is the point 7 over 2, comma 2. Pretty easy. Okay, I drew my parallelogram, PQRS. Angle P is x squared. Angle Q is 11x. I know together they have to add up to 180 degrees. So I bring the 180 over, because whenever I have an x squared problem, I should make it equal to 0. And now what I should do is factor. So if I set up my x, top number is going to be negative 180. The bottom number is going to be positive 11. I have to think of two numbers that multiply and add. So when I see that, I think negative 9 and positive 20 gives me my positive 11 in addition, and negative 180. So I make these x's here. I get x minus 9 and x plus 20 is equal to 0. And when I solve, I get equals 9, which is good. But x equals negative 20 is an algebraic solution. If I plug negative 20 in here, I would get x squared, it would be 400, and this would be negative 220. I can't have negative angles or angles that are 400 degrees. That doesn't make sense. So, 9 works because 9 squared is 81, and 11 times 9 is 99, and together they add up to 180. So to show that the quadrilateral ABCD is a parallelogram, first I'm going to show that the opposite sides are congruent. I'm going to use that distance formula that we've done before. The distance between 2 points is the square root of the change of x squared plus the change of y squared. So I'm going to show that AB equals CD and that BC equals AD by doing the distance formula a couple times. So the distance of AB is the change in x is negative 3 to 2 is 5 squared, and the change in y is 3 to 5, which is 2 squared. I get square root of 29. And when I do CD, I get exactly the same result, square root of 29. So AB and CD are equal. Now for BC, the change in x is 3, the change in y is 3. So 3 squared plus 3 squared, I get the square root of 18 is the length of BC. And I get exactly the same when I do the length of AD. So BC and AD are congruent. That means I have AB equals CD, BC equals AD. That means quadrilateral ABCD is a parallelogram. But now I'm going to show you another way that I could show that I could prove that it's a parallelogram by doing opposite sides and slope. Another way is to show that the opposite sides are congruent and parallel. So I already know that AB and CD are equal to each other from the first step I did. Now I'm going to show that the slope of AB is going to equal the slope of CD by using my slope formula, change in y over change in x. So I did my formula for slope, and I showed that the slope of AB and the slope of CD both equal 2/5. That means they are parallel since they have the same slope. So if AB and CD are congruent, and AB and CD have the same slope, which means they're parallel, that means it is a parallelogram.